This is the spectrophotometry and Beer's law experiment. And here we are starting to make the standard solutions. And so we're pipetting the stock solution of Allura Red, the 1.00 times 10 to the minus 4 molar solution, into a 10 milliliter volumetric pipette. And we want to do that so that the meniscus of the solution just touches the line on the volumetric pipette. And so now we know for sure that there are exactly 10.00 milliliters of solution in the pipette. We would then transfer it to the 50 milliliter volumetric flask. And notice that we don't want to force the liquid out, we just want to allow it to just drain out. And then we would add deionized water, again up to the line that is on the 50 milliliter volumetric flask. And that would ensure that we have exactly 50.00 milliliters in there. So the last few drops we would actually add with a dropper, again to make sure that we don't add too much water. We want the meniscus, the bottom of the meniscus again to be at the line in the volumetric flask. And the last step would be to make sure that everything is mixed thoroughly. So we would invert the flask and shake it to make sure that the solution is fully homogeneous. And so this is what all the samples look like, all of the standards made by using different volumes of Allura Red stock solution. And we could see that they're clearly different concentrations because the color changes as we go from lower to higher concentrations of Allura Red in the dilution. And if we take one of those samples, this is what the spectrum would look like. And this is the absorbance as a function of wavelength spectrum. And so we could see that the maximum wavelength here is that tall peak at 502 nanometers. And so this would be lambda max.